All right, so for today's deep dive, we're going to get into a piece of tech that, I mean, on the surface, it seems pretty mundane.
Yeah. The NTI E-AV-LC-7.
Exactly, the air velocity sensor. But I think there's a really interesting paradox here. You see low cost on the label, it's about, what, $225?
Right.
And you have to wonder, how can something like that be a foundational piece for a huge enterprise-grade environmental monitoring system?
That's the core question, isn't it? Because in a data center, airflow isn't just a nice to have. It's basically life support for your servers.
Okay, so this thing is like a watchdog.
A silent watchdog, exactly. It connects directly to NTI's and VeraMUX systems, the E16D, E5D, and it tells you the second that cooling airflow changes. That's often your very first warning sign.
So let's dig into that low-cost label then. If this is supposed to prevent a thermal disaster, what kind of performance are we actually getting?
Well, this is where it gets surprising because the specs do not feel low cost at all. We're talking about a range from 0.
From a dead stop.
Exactly, a dead stop, all the way up to 82 feet per second, which, is incredibly fast.
That's faster than a person can run, right?
Oh, absolutely. And the accuracy is really the key. It's plus or minus 1.6 feet in its main operating range. It's a level of precision you'd expect from a far more expensive industrial sensor.
And it holds that accuracy across a pretty wide temperature range, too, from freezing up to almost 16 OSEF.
Mm-hmm.
Which brings me to the construction. The probe is made of PA2200 plastic. Why does that specific material matter?
Because it means it doesn't have to just live in a perfect climate-controlled server rack. PA2200 is tough stuff.
Right.
So you can actually deploy this sensor in tougher spots. Think near cooling towers, inside ductwork, or even at outside air intakes to get a full picture of the thermal system.
Okay, so it's accurate and it's tough.
Yeah.
But let's talk about range. I saw the standard cable is just 7 feet. That doesn't feel very enterprise.
You'd think so, but that's where the smart engineering comes in. It ships with an RJ45 coupler.
Oh, so you can just extend it.
You can just extend it. With standard Cat-X cable, you can push that signal out to 1,000 feet.
1,000 feet? Wow. Okay. And why would you need to go that far?
Because monitoring often needs to happen really far from the central hub, especially in large facilities or, say, industrial settings.
And 1,000 feet isn't even the limit, is it? I saw something about a fiber converter.
You did. With the EFSC fiber converter, you can extend this sensor up to 1.2 miles away.
1.2 miles.
2 kilometers, yeah. It just completely changes where you can place these monitoring points.
Okay, but I think the number that really blew me away, the metric that truly defines this as enterprise grade, is the reliability figure.
Ah, the MTBF, the mean time between failures.
Yeah, that number, it's what, 1.3 million hours?
1,387,280 hours to be exact.
Which translates into how many years?
It works out to over 158 years of predicted continuous operation.
158 years. So, I mean, the takeaway is pretty clear. This component is not designed to fail.
That's the bottom line. For a low-cost device, failure is just not considered an option.
So if we pull all this together, we're not just looking at one sensor in a vacuum. This is clearly one piece of a much larger ecosystem.
It has to be. You see it with their other low-cost products, the hydrogen sulfide detectors, the CO2 sensors, pipe temperature monitors. They're all designed to plug into that same central system.
So you're taking this incredibly detailed local data point airflow and integrating it into this huge campus-wide picture of environmental control and safety.
Precisely. And that's why the regulatory approvals are so important, too. The CE, RoHS, and especially the TAA compliance, which makes it eligible for U.S. government use.
Right. So that leaves us with a final thought for you to chew on. We've established its extreme reliability, that 158-year predicted uptime, and it has all these government and international approvals. The question is, what other specialized applications, I mean, ones that go beyond even a military data center, would demand an air velocity sensor that promises that kind of extreme, almost unbelievable endurance?